Good afternoon, everybody. Thank you all for joining us for this afternoon's seminar. I have just a couple of reminders for folks. One, if you're associate professor and higher, you owe me a letter for Olga's promotion with tenure, so please get that to me. I know who you are, and I will be coming after you next week if I don't have those in. Second announcement, a little less threatening, is we are starting, this is Chad Start, is the beginning of our fall seminar series. So next Friday, we will have our second speaker, Dr. Jose Denny, and I believe Tomo is hosting that individual. So look for Jose, and for those of you that have lunch with the speakers, watch for an announcement from Zoe to sign up for lunch. It's my pleasure today to introduce one of our own. You guys all should know Dr. Chad Lee. You may not know Chad is from Ohio originally. Got his bachelor's degree in agriculture from Berea College, just down the road, and then went to Nebraska-Lincoln for a master's degree in agronomy. From there, he came to Michigan State and got his PhD in crop and soil sciences, and it looks like finished getting his degree while also being employed at Michigan State. He was actually a weed science specialist while he was finishing his PhD. He started here as an assistant extension professor of grain crops in July of 2002, and he has been here ever since. You probably know that these days he carries a double role. He's also the director of the Grain and Forage Center of Excellence, and he's been in that position since 2016. So with that, please help me welcome Chad.
Thank you, Rebecca, for the introduction, and thank you for the reminder. You'll have that letter by the end of today. Thank you all for being here today. I appreciate it. I appreciate the lunch with the students earlier. It was encouraging for me to sit with the students and have a conversation. Hopefully you all enjoyed it as well. So Rebecca gave you some of the background. Those of you that know what we work in, you know we work in this area of row crop production, no-till, and we've been doing some work in the cover crop area and some things like that as well. And so that's where we get to with this title of Making Regenerative Ag Work, or actually work in Kentucky. And so that's the conversation. I'm hoping today to do a couple of different things. One, give you an overview of some of our research, and we're just one small component with a larger group. I'd like to give you an overview of some of the farms and farmers and what they're doing in this area to try to make this work for them and make this work for the markets that they're trying to sell into. And then finally, hopefully, as we go through that overview, one, you may have a little better idea about what farmers are facing and what they're actually doing, but two, maybe there's some research questions that come out of this. So I think there are. Hopefully you'll agree with that. And so if you've got questions as we go through this, please feel free to ask me those as well. Our computer doesn't like our USB outlets, so we're going to give that a try here and see if that works. So, Dr. Egley, I put this slide in just for you. Population is growing rapidly. We've got more and more people to supply food to on a regular basis. And projections are pretty strenuous that we've got a lot of demand to keep up with as we go through. And so three questions come to me, and I think three questions for most everybody in this department, frankly, and the college are working on. We may not always frame them in this manner, but how do we produce food, enough of it for growing population over time? How do we minimize our environmental footprint? And then this question at the bottom, can it nourish that population with increasing demand and maybe even help the environment in some ways? And so those are three of the underlying questions that hopefully we'll cover a little bit today in the conversation. End users of grain are expecting agriculture to be part of the solution environmentally, not just a footprint negative, but a footprint positive, if you will, in that regard. And so if you look at one of the models that's being used right now, it's called the Cool Farm model. I don't want to get deep into the details on it here, but if you compare a no cover crop to adding a cover crop into the system, a cover crop almost magically reduces carbon by a tremendous amount of kilograms per acre over the course of a growing season. This is an assumption on a no-till corn, and there's other numbers in here. This is a massive, massive number. And I would say, cover crops can help, yay. I'm not quite so sure that those numbers are necessarily accurate. And there are some discussions that we're having with farmers and others in the supply business of, well, do we just stay satisfied with where that number's at? And every farmer that's growing cover crops is checking a box, because this model makes no assumption about cover crop biomass for the students in the room. It makes no assumption about planting date and termination timing. It's just a box of yes, cover crop, or no. And if it's yes, we pull all the carbon out of the environment. Aren't we good? Okay, somebody can laugh at that, please. All right.
I like that you check the box, Chad, rather than do more science in it.
There you go. That's right. Yeah, well, I mean, sometimes in sales, once you've made the sale, you quit talking. So that's part of it. Back to these ideas of how our end users are expecting farmers to be part of the solution. It's already in their business models. It's already in their projections for how they intend to reduce greenhouse gas emissions over time. And so I've just got 4 listed here. Essentially, every major buyer of grain in Kentucky has statements similar to these. Okay. And so it's reducing scope 3 emissions by 25% by 2035, getting to net zero by 2040, 40% reduction in scope 3. And the term scope 3, who's familiar with the term scope 3? We got 1 or 2. I won't put you on the spot, but scope 3, for the purposes of this discussion with these companies, every farm fits into scope 3 for them. These are energy that the farm uses to grow a crop that company isn't using directly. So that falls into scope 3 category. If you read their materials, they expect a lot of their own reductions that they can calculate to come from scope 3. Do you follow me on that? They expect a lot of the reductions not to come from their own distillery or mill or packaging plant. They expect it to be coming from those that are supplying them in here. Okay. All right. The other part of this, there's a lot of words up here. This is word dense. For those in the back, I apologize. But I'm using the same companies I used the last time. Every one of these companies has some term either to regenerative ag or sustainable ag. I didn't put it on the board, but Nestle says by 2040, every one of their ingredient suppliers will be a regenerative ag farm by 2040. So that gets into this question of what is regenerative ag, right, Tim? So where do we go? And regenerative ag is a lot about diversity, and that's evident by the diversity of definitions that you see from the companies trying to define regenerative ag. Again, you can laugh. You guys are tough. It's a tough crowd. All right. So if I try to synthesize it all together, there's some common themes and some common practices that come into play with regenerative ag. And so resilient yields, sequester carbon, improve soil health, those are all pretty consistent with most of the different companies that state what they think regenerative ag is, companies and organizations. Look at some of these common practices: no-till, low-till, cover crops, living roots, crop rotation, animal manures and compost. Sometimes it involves integrated grazing in the system in there as well. And so of those, these 3 are the ones that where I work in and where our research is based. I will say, just step back for a moment. A couple of years ago, before COVID, I went over to England to look at Rothamsted and their long-term plots, trying to decide if we should do some other similar type long-term plots here. I met a farmer who, really intelligent guy. He said he'd tried organic. It didn't work because of the labor, the diseases, the pests that they've dealt with. And so now he's into regenerative ag, and he really likes what it's doing for his operation. And I said, well, explain that to him. And he says, well, it's no-till and cover crops. And I looked at him and said, oh, our guys have been doing that since 1960. And he's like, you're kidding. I had no idea. So I got into a really good conversation. I probably said it more rudely than I meant to. I was on 2 hours of sleep, and I'd just driven an hour and a half on the wrong side of the road. So there's little room for slack there. Okay, in this cover crop area, I'm not the only one at the university working on this, so please don't look at this and think that we're the only ones in this area. There's some folks doing lots of good things around. We're partners on some of these overlap as well. But just getting into some of our area, I show this picture a lot because this came from one of our farmers who's doing cover crops. I like this picture. In February 2016, 7 inches of top growth. He dug down to 18 inches. That's as deep as his shovel would go in the cold weather, and he found roots at 18 inches. We borrowed a Giddings probe and gotten down to 30 and found roots at 30 inches at about this stage as well. So cover crops are sitting roots down deep, holding soil in place, good for erosion. Cereal rye is by far the most popular cover crop being used, and that's where most of our studies started out, was looking at cereal rye. From my perspective in the row crop business, we want to maximize our yield with any of these systems. And so we studied the one that's the most common. We studied one that's very easy to establish and that has a high success rate in our system, and that's cereal rye. And then those of you that remember Dan's study, he was able to show early on in some of these studies where the cover crop remaining behind actually showed some visual symptoms of nitrogen deficiency in corn at about the V6 stage relative to where you had no cover crop. So we saw evidence of competition from that cover crop. In this case, we were terminating the cover crops 2 to 3 weeks before planting, but even that early termination, there's still decomposition taking place, and that was still taking nutrients away from the corn crop. So we saw these interactions taking place. I'm not going to go through the study other than we had a good one, and I'll get to some of the main points here. If we look at this, and this is coming through pixelated, I apologize. This is hard for you to see. So what I will do instead, I'm going to bring this up, and this is being converted over into pounds per acre. Over here, we've got an agronomic optimum N rate, an AONR, and an economic optimum N rate, an EONR. And Grant, we could argue about what's the right way to go about this. Jordan helped us with these numbers. We had an economist on the committee with Hannah as well. And so looking at these values, we've got without cover crop, everything pre-plant, or most of it at side dress. And side dress was about V3 to V4 growth stage in corn. With the cover crop, pre-plant versus the side dress timing as well. If you put all those values together, we averaged about 206 pounds of N per acre that we needed on a well-drained fields on 3 locations, 7 different environments across the state. Economically, we needed 6 pounds less. We were pretty close, and doesn't always play out that way. There are years and there are scenarios where the agronomics and the economics may have a 20, 30 pound difference showing up in their numbers. But for this study, that's where it came out to be. Take a detour for a second. So we're doing these on farmers' fields as well. This is the interaction of what we hope farmers do to make changes based on our research. And then we can talk about some of the consequences that come from that as well. So in our detour, I'm putting this up first because this relates to the story I'm about to tell. So Hannah's been looking at the data from John Grove's long-term no-till rotation studies. And in those long-term no-till rotation studies, the agronomic optimum N rate, the AONR, is between 170 to 180 pounds of N per acre, whether it's tilled or no-tilled. And Hannah, if I'm saying anything wrong, you can correct me on this. Okay, so here's the challenge. So the farmers, where we were doing these studies, saw our 200-pound N rate as being the optimal N rate in their fields based off of our studies. And so now they've made that their application rate, right? We've got the science behind it. The data's published. Dan's now a professor at Purdue, so it all worked out, right? Got to be good data. So the farmer did that. AGR1 maxes out at 165 right now. It's not a slant against AGR1, but the farmer also signed up for programs through NRCS for cover crop and nutrient management and crop rotation and some of those things. And the program will pay out different dollar amounts based on what that farmer's doing on a per acre basis. The 3rd year into the contract, the farmer found out that because his nitrogen rate was higher than AGR1, he would not be getting paid anymore for his practices. A nitrogen rate he's following based off of research we've done on his farm. So now we've gotten into a sticky situation. So there's some things we need to change. NRCS has changed locally how they're interpreting the regulations. They've decided to do it this last year. They're putting all the blame on AGR1. I'm not sure that that's quite fair either. But sometimes our positive impacts can end up with other challenges as well. A farmer can max out at $40,000 in that program. And so if they went into the spring and the summer expecting $40,000 from a program, and they get to the fall and they don't have it, that's a budget hit, right? So there's some challenges that we deal with as well. Our research does have consequences. Hopefully they're usually good. This is one we're working through right now, and hopefully we can resolve this before the next NRCS season kicks in. All right. What we found in Dan's papers were we needed to terminate that cover crop early, so 2 to 3 weeks before planting corn. If we were concerned about a high success rate for yield, we didn't want the cover crop to be late and get very large for us and have corn trying to establish through that. So those were some of the things we learned from that. We found out that in the case of a rye cover crop, it is competing with corn for nitrogen. And for the most part, we're recommending that a side dress is better than putting it all down pre-plant. I showed you the averages. The extremes are if we put everything pre-plant, it requires as much as 70 pounds more in per acre than if we wait and do it at side dress. On the extreme. On the average, they were very close, but on the extreme, it can require a lot more in. So side dressing, delaying the application of most of the nitrogen was beneficial to us in that scenario. It was also beneficial when we didn't have a cover crop. And this is probably the first time we've documented this positive response on well-drained fields in the state. And right now in AGR 1, our recommendations, we don't necessarily recommend split applying nitrogen on well-drained fields because the data hasn't supported that in the past. Dan's data would suggest that we should split apply. It might be a function of higher rainfall events that we're dealing with now, maybe a function of the yield potential, yield goals, not yield goal, but the yield potential of corn now, the actual yield that farmers are getting on their corn, and maybe some other functions in there. All right. Most of you are still with me, that's good. From that, so rye produces a lot of biomass, really aggressively growing winter annual. It's great for cover crop for all of those reasons, but what about wheat and barley? A lot of wheat's already grown in the state, traditionally in tobacco fields. We have access to a lot of wheat. We grow about 400,000 acres of it every year, so there's plenty of it around in that regard. And then the barley overall should produce less biomass. And so by producing less biomass, our question is, will it be less competitive with the corn crop for nitrogen? Will there be enough of it there to hold soil in place and still do what a cover crop should do for us? And so that's largely what Rob's studying. And I'm gonna give you some highlights of this, of what Rob's doing. So Rob's still in the middle of, well, we're still waiting to harvest data for this year, but still learning how to analyze and run all of his data and such. I'll start with this. This is out of Spindletop Farm, 2 to 6% slope. You can see our cover crop passes. You can see where we've got soybean residue, where there's no cover crop in that area, and you can see that the residue has been removed and we've got some erosion taking place. And just doing some back of the envelope calculations, you can see the tape measures out there. We did some volume measurements. Back of the envelope, if that were consistent across an acre, that's 75,000 pounds of soil. Obviously, it's not across an acre, but you get an idea that there's a fair bit of erosion that can take place in a long-term no-till field where we've got high soybean yields, high corn yields. We just don't have enough soybean residue to hold soils in place on a 2 to 6% slope. And we have farmers that farm steeper than that in the state. So there's a real need for cover crop. JD and I used to joke all the time that, well, winter annuals are just an all-natural cover crop. They help us out. We had some winter annuals in here. You don't see them in this picture. The winter annuals don't have the root mass. We're still getting erosion taking place when we have just winter annuals in the field. The first year we did this was before Rob got here. It was just a very quick study. And by that, I mean, we put out the corn, we put out the nitrogen rates. We had the 3 cover crops, and we were just looking to see what would happen from it. We didn't take a whole lot of data off of it other than establishment and yield. I think we did a series of measurements, maybe some SPAD readings right around R1. Ultimately, corn did a little bit better following barley than the other 2 cover crops. It actually did a little bit better than our no cover crop. And so that made us scratch our heads. One environment, one operation. The barley yields were low, but ironically, wheat was actually the lowest in that particular study, which was a surprise to us as well. So we've expanded the study. We're now in Hardin County working with a farmer the same farmer that has the nitrogen rate issue. We're back on his fields again. He's planting cover crops for us, letting us do some rotations with him and working with us. We appreciate that. Pulling off biomass samples, that's a picture of Rob in the bare soil where we've just got winter annual weeds, just so you can see what he's using to cut with. If I took that picture in rye, you just see his hands buried in green grass and you can't see anything else. So anyhow, oh, I scared him away. I will tell you, harvesting winter annuals by hand in soybean stubble is not fun and dangerous to your fingers. Much easier to harvest cover crops when there's a little bit more biomass to grab a hold of. What we found the last 2 seasons, 3 in different environments, is what we expected. We saw less biomass with our barley. What we didn't expect was that wheat produced just as much biomass as rye, one case more. This year at Lexington, a lot more. Again, we're still targeting that 2 to 3 week window before we plant to terminate. We'll probably have to change that recommendation in 2 to 3 weeks or a certain biomass amount to work with. So we got a lot of wheat, over 4,000 pounds of wheat this year produced in above ground biomass off the studies. Again, 2 to 6% slope. This was the Hardin County location. This is barley. This would not be an acceptable stand of barley. I was concerned that this was too low. This is not what we'd want if we were growing it for grain. But what you see in this image is this is the soybean residue here in the bare area with just the winter annuals covering it. This is the low end of the field by the slope. And so all of that residue has been carried down slope and pushed to the bottom. You get over into this barley, which is a poor stand, and the residue's holding in place. Residue's holding in place. So even a low stand of barley that we weren't comfortable with, still gave us 1,500 pounds of biomass, is helping us reduce some of the erosion. And so I'm going to speed up just a little bit. We've got basically 4 nitrogen rates, well, 5 technically, with those cover crops. And let's get into a little bit of what Rob has seen so far at this point. From 2022, SPAD readings with and without the cover crop are basically the same. Again, 2022, these were low cover crop yields, very low yields. We were late on planting the cover crop. We terminated it early, very low yields. But looking at the nitrogen content at the ear leaf at R1, we see that each of the cover crops resulted in slightly lower nitrogen contents. This is averaged over all the nitrogen rates. We are seeing a cover crop effect, even with low yielding cover crop. That's of interest. What does that mean? Well, we got to yields last year. It didn't mean anything for yields. Didn't mean a thing. We were good all the way through. But it does tell us that there is still some competition taking place that we've got to pay attention to. And if we look at these actual N rates, this is just bar charts. At some point, Rob will learn how to put all this into R and regression on it and run it that way. But what we see, so look at the blue, that's the at plant timings, the yields, and then the orange are the side dress. We're still getting quite a bit of a yield difference with the side dress application. There's still some advantages to side dressing going on in well-drained fields. Mentioned we had high biomass this year in 2023. High biomass, I don't know if it was the biomass itself or not, but we also had slugs come in and we had birds. Poor Rob's study went down to 50% stand in a matter of about 3 days in that process. So we had to terminate this corn and start again. And so what was supposed to be a 2 to 3 week termination timing ended up being about an 8 week termination timing and a replant, something that farmers deal with all the time. Any farm that does cover crops is going to have a field at some point they replant. That's accepted. That's just part of it. So if I do an overview on it, we've documented that the cover crop is capturing some excess nutrient. It's reducing erosion. Those are good things. It's also, it can capture excess nutrient. It can also compete with corn for those nutrients. And so that's what we want to try to avoid if we can. The N and sulfur together, the sulfur's coming off of Hannah's studies, not our studies. We'll see this year if the sulfur behaves that way. And then the cover crop can harbor organisms that like to eat corn as well. So that's something we have to work with. And some of these others are just individual observations that remain to be seen just how exactly they work out when Rob gets through analyzing the data. Ultimately, though, we've got to manage these cover crops so that we're maximizing the cash crop yield and economics. If the farmer does not stay profitable, the farmer's not going to put cover crops in. I probably can't stress that enough. If a farmer is not profitable, they're not going to invest in a cover crop and go through the expense and the labor and some of the time and management that it takes to manage a cover crop. They're not going to do it if they're not making money on the cash crop. Everybody with me on that? Makes sense? And the NRCS programs, those things at the moment aren't paying enough by themselves to justify most of our farmers going into it. So if they're going into it, they go into it knowing that it's a long-term gamble, that it's going to pay off down the road in better soils, better quality, some of those things. So Rob's busy. Rob's got a lot of data to analyze this fall, present. We're probably going to go forward with barley and probably put a legume in with it as well, mimic a little bit of what Hannah has done in some of her studies on rye and legumes. We're looking at Austrian winter pea. We grew some of those last year for a different project. We got about 40 bushels to the acre off of winter peas. That's not bad. So it looks like it ought to survive a winter and do okay as a cover crop. And it was fairly pliable. It was kind of easy. Looks like it'd be easy to cut through and operate with machinery and such. So as opposed to something like vetch, which can cause problems on planters. So, all right, let's go visit some farms. Everybody still with me? Okay, let's go visit some farms and go through some of this. And so hopefully in this process, again, an overview of some of what these farmers are doing, maybe a couple of research questions that come out of it as well. We're going to start out in Western Kentucky in Hopkinsville. This picture looks familiar to Dave McNear and should look picture of the folks that are on farm camp this year. This is one of the farms out there that they visited. Most of those farms have wheat in their rotation. So corn, winter wheat, double crop soybean, 3 crops in 2 years. We can step back for a second and I can make the argument in many ways that wheat for grain is the very best cover crop we have. All right, in terms of the biomass it produces, in terms of the farmers getting a cash crop out of it and adding value that way. These farmers are very committed to putting another cover crop in after soybean harvest and before corn planting the following spring. So they're keeping those fields covered probably 23 out of 24 months. Something green on it, probably 23 out of 24 is what they're close to right now. That's pretty good. That's really good. When you consider the typical rotation, a field is bare for 6 months, right? Everybody with me? Okay. Some of the challenges. This is double crop soybeans. Y'all see the holes in there? These are sprayer tracks. These little lines in the field are sprayer tracks. There's probably about 90 feet between tracks in the field to give you some picture of scale. And these little critters here like to eat soybeans when they're young. They love no-till fields. They love fields with heavy residue. Their little burrows and tunnels and such are very shallow, 1 to 2 inches deep for the most part. Their homes are deeper, but they'll hang out in these fields. And so almost every farmer that's in no-till, especially farmers that have wheat in a rotation, have at least one field that has voles in it that they're trying to manage. So I showed you slugs. I didn't show you the actual slug, but I showed you the result of slug damage in Rob's fields. This is another issue as well. There are other studies by wildlife scientists that show that no-till promotes wildlife. Our farmers would say we know. Yes, this is not the type of biodiversity we want out here. You guys are a tough crowd today, I tell you what. Okay. All right, come back over to east. So Clark County, just 1 county east of us, neighboring. This is really, really close to our Fayette County line right here. This farmer is actually just the opposite. He's letting his rye get super tall. He's crimping it over. He's terminating it with herbicides. This was the first year he did it. He called me up and I said, oh my goodness, I did not realize. And then a couple of days later, this is the field planted with it all terminated. And instantly my mind went to, there's no plant pathologist in the room, but my mind went to the slug issue that we dealt with. And it went to what kind of diseases are out here. He's asking this corn to get up through this mat. This picture, I have pulled essentially the mat of rye away to find the corn plants down there. I thought for certain this was going to be a disaster. It wasn't. It was a poster child for how crimping rye can work in a field and make it work later. Now, I will tell you, the grower put on quite a bit higher nitrogen rate to compete with that. And the grower put on a couple of extra pesticides to handle some of the insects and other things coming in that he had to fight with as well. So there are trade-offs on this. This grower wanted to maximize biomass. He's wanting to protect some soils. So he's going after a little bit different angle with this. A lot of farmers are doing this, doing that route. A farmer down, this field is actually in Robertson County, Tennessee. This farmer farms both sides of the line. He wears an ugly orange hat with a white T on it on a regular basis, but he comes to a lot of blue and white events on the ag side. And so we visit with him. There's several farmers down in that area that come to and are part of our programs on a regular basis. And so he was hosting a young farmer group this summer. We were out visiting his farm. And I'm going to show you this. This is out of some NRCS work that he's doing on his farm. He's got 5 species, 3 species, no cover crop. He's been doing it for 4 years of data. The 5th year is in now. They're basically the same strips in the field. The problem is they're all just a single strip. What can we do with data from a single strip? Not a thing. NRCS is analyzing it, putting economics to it, and telling the grower he's making all kinds of money growing a cover crop. I have a little bit of an that bothers me. That bothers me. They can at least do 2 strips, or at the very least, average 4 or 5 farms together and give those numbers back to them and run some numbers that way. You know, this is a scenario where the farmer's trying to do some really good practices and in my opinion, getting some misleading data along the way. It looks like, I know these numbers are hard to read, but probably 3 of those years, those yields probably all, my guess is they all fall within a 1 LSD of each other. They probably all were within just a few bushels of each other and probably no statistical difference if we'd had replications to work with. The same token, the farmer's ready to do this over thousands of acres because the farmer wants to make this, wants his soils to be better and wants to make this work. I think there's an opportunity to work on some of that. Some of you are working with multi-species cover crop mixes. Some of that data is useful for a grower like this. Okay, different challenge that some growers are working with. These growers have a satellite imagery. Up in the top corner of this is some crimson clover and triticale. In the bottom part of the field is crimson clover and rye. They sent some of their crew out to pull samples out of these spots and out of these spots to get estimates of total biomass and estimates of the legume biomass in there. From this imagery, they estimated how much nitrogen would be available from that legume for the corn. Okay, you all follow me on the steps? So their total biomass, the legume, and then the nitrogen component. And from that, they developed variable rate nitrogen prescription map to put onto this field. And so over here, this purple is a lower rate of N, an intermediate rate, and a little bit higher rate. Then they have fixed rates or static rates in both areas of the field. They're going to use those static rates to compare against their variable rate to see whether or not they came out anywhere close to their expectation on this. Now, does anybody see a researchable question in here? Would anybody like to have that data right now to run a study on? Because there's some good data right there. All right. So I think there's some things we can chase that way. In addition to that data, so they pulled off the biomass, they've got the satellite images, they've got a soils map, it's digitized, possibly adjusted. I'll talk about that in a minute, what that means. They've got soil test data by zones, they've got their soil amendments with variable rate, lime, PK, anything else they put on the field. They've got years of yield history by their maps as well. Their planter will tell you the population, the spacing, the depth, the soil moisture. It'll tell you the pressure at each spot where a seed was dropped. That's an estimation for compaction. And I'm not certain, I didn't write it down here. I think it's also given an estimate for soil temperature at each spot when that planter goes through the field. So you're talking about a tremendous amount of data that's being generated at that point. If they've got a spot in the field that doesn't look right, they can go back to this planter data and see, is there a number off? Were we shallow? Were we too deep for some reason? Was something else behaving improperly? They're running UAVs, fixed wing UAVs over this to getting multispectral data. They told me that last time I talked to them, they're working with a third-party group to process about 1 terabyte of data a night. And then they're going back into fields and trying to determine where they see problems based on their multispectral data from their UAVs. Then, of course, the harvester, it's giving them a yield map, moisture, test weight. Of course, all of this is geo-referenced across the field. To me, there's for somebody who's better at statistics than I am, particularly with the complex statistics, there is a minefield. I meant that the proper way. There's a lot of data. What's a better term? There's a truckload of data. A gold mine, thank you. Yeah, the nano specialist right here working with gold. All right. Yeah, there's a gold mine of data in here that could be worked with. And they're doing this on 2 or 3 fields. So there's some really cool things that come out of this right here. So I'm really intrigued by some of this that they're working with. Anybody got any questions as I'm rolling through these? Yeah, Grant's got one.
Yeah, are those test strips, or what are they putting on the right and left side of that field there?
Right, so right here, these test strips.
Yeah.
So they've got 3 different rates of nitrogen that they've applied, and it's just a constant rate. So the red, the green, and the blue, I don't know what the rates are. This blue blend, so the blue here and then this blue strip are the same rate. So that's sort of their check to whether they're okay. And then up here, they've got the blue, the yellow, and the red, which I guess this yellow and this are the same, but I don't know what the specific rates are. But these fixed rates across the landscape position and then across these estimations of biomass, they can go back in and figure out whether or not these fixed rates, whether or not the prescription map was anywhere close to where it needed to be. Thank you for asking the question. That means I didn't explain it well earlier. Yes, Mike.
Well, I say Scott's name up there, but this reminds me of when we first started getting data from Precision Ag. It's just, as you say, there's so much data. You're talking about what you could do with it. What are they going to do with it?
Well, great question, Mike. So Mike's asking, for those online, Mike's asking, well, what are they doing with all this data? There's a huge amount of data. The reality is a lot of it stays on the computer, gets printed out into a real pretty 3-ring binder or 2 or 3 of them. And that's where it is. They'll look at the yield map when they get done this fall, and they'll all have a yield map with the different pictures, different color coding on it, and they'll see, well, does it match this? Can we see what's going on here? And if it does or doesn't, they'll eyeball it. Thank you. Yeah. Yeah. Thanks, Mike, for simplifying the terminology. They'll eyeball it. That's exactly what they're going to do. And if something looks off, they can go back in and they'll do some comparison that way, because Scott's got some training in that area.
Sure.
Do a little bit of that. Yes.
It looks like the rates aren't the same, or yellow and green, or
That's correct. They're not quite well. So the red one would be the same rate on both sides. The yellow, the blue is the same rate, but this green and this, yeah, the blue and the red are the same as these, or the, yeah, that blue, that yellow are the same as this yellow and that blue there. But you're right. This green rate's a different one. It's an oddball. I don't know the difference. My guess is because this was perceived to be lower biomass, this demanded higher nitrogen. And so my guess is that green rate is well above what they think it ought to be. That's my guess. Okay, good questions. Others? All right, we'll roll on. So anyhow, yeah, it's all geo-reference. So yeah, so those are some of the questions. Which one's better? Can the satellite image even accurately do this? Is this even a good way to go about it? Can they do it with a drone instead? Is there a way to put a fixed wing drone out there and give that estimate and give that number back? And frankly, how accurate are the estimates for a crimson clover has this much biomass and, based on the studies, has this much nitrogen, and how much of that is actually released for the corn crop that year? So there's a myriad of questions that can be asked just off the one study, I think. All right. Different farmer. This is over in Clark County. He sent me this picture this summer because I was out earlier in the year. So this is the soybean field here. You can vaguely see in this image some darker color beans here. In terms of darker, I mean more of like tans and some reds showing up, some yellows. And then on this outside edge, it's a little bit different color, and it really picks it up here in the multispectral, right? You can see the middle of the field really stand out. This outside edge had cover crop. Inside did not. Last year it was corn. Now it's confounded because there's 2 different harvest dates on the corn. So some of this corn was cut for, the outside edge was cut for silage. They planted a cover crop in right afterwards. The interior was left and cut for grain. So there's confounding that way, but he's picking up off of this imagery a treatment effect that either is attributed to the cover crop or the corn harvest timing or both. should be options in a year like this when we run short on water to pick that up over landscape positions on others. And I'm sure, because I know what Scott's using out there in their farm, I'm sure they've got these images as well to look at some of theirs they're dealing with. Yeah. Okay, that gets me to this. So the strip till system. So this system this system is I shouldn't just call it strip till. This is strip till with a cover crop. The two have to go together for the system to work, what it looks like so far. Micah Lester at Lester Farms. Micah is a 3rd generation no-tiller, 1st generation strip tiller in this regard. He has decided to go complete controlled traffic. So he's planting cover crops with precision guidance planters. He's coming back in and planting his cash crops in between the rows where he's leaving strips in there. And then every unit of equipment he's got is set up on 40-foot increments so that he's using the same passes through the field every time. Even his grain carts that go to pick up grain off of a combine, they'll go to the combine and pick up the grain, and then they go right back over to one of the tram lines in the field. But he did that because he was having issues, the same issues that Rob had in his field, the same issues other farmers have had, of letting the cover crop get big and then having issues with getting corn established and getting a good corn yield. So this is a marriage between keeping a cover crop in there as long as possible, but still getting good corn emergence. My biggest concern was erosion. What's going to happen with these open areas, these open strips in between over the course of a winter in our climate. Everybody with me on that? Okay. So day of planting, about a month later, a different farmer in the area, looks pretty good from that image. This is a different farmer, Joseph Sisk. He's also doing strip till. Same scenario. Early on, he and I walked some fields, and just anecdotally, we were walking fields, and anywhere that the planter got off of the strip and got into the cover crop, we could document a reduced stand. We got back out into the strip, and we could document a more even stand of corn in there. So we were picking up stand differences that way. Now, 2 years ago, we all went out and we did a study where we did, 10 locations in the field and about 8 different fields, and we tried to document all of that. And our standard variation was very close. We didn't quite have the difference when we actually put some numbers to it that way. Probably some more to do in that study. So in this scenario, this farmer terminates early. He was, the official term, Mike, is he was burned by cover crops once, so he's not going to let them burn them again. So he terminates at least 3 weeks ahead of time, if not 4. He's maintaining the strips. This planter is going through and planting in the strips. And that's an image of it there. Now let me zoom in. I've zoomed in the best I could with this. I apologize. So this is a corn seed in the furrow. You've dug down at this point 2 inches to find it. And what I saw all the way through are the roots of the old cover crop. In fact, as I dug down through and dug around, there was a netting of cover crop roots. So let me back up. So this is all burned down. It's all dying. It all looks brown to you. It doesn't look that impressive at this point. But in those strips that were established, there's a netting of roots that have gone across there and are holding those strips in place. So just again, anecdotally walking fields, I'm not seeing gullies. I'm not seeing evidence of erosion like I saw in the soybean field I showed you earlier. So there's something to it. And they're keeping this off of steep fields. They're not putting this on steep fields right now. But they've said they've gotten a little bit steeper every year. They're trying a little bit steeper slope every year with it because they've had success with it. That day of planting in that field, so this field I just showed you where I had dug down and found the seed, a 9-degree temperature difference that particular day at noon in that field. Now, if we'd had monitors out throughout the season, if that's consistent, if that was a consistent temperature difference, that means the corn in the strip is going to germinate 5 days sooner. And there are other studies that show that if corn comes up quickly, uniformly, it usually leads to better yield. Not always, but usually. So this would suggest that it's leading them toward that path. Okay. The other farmer I mentioned, Micah, this is his system to put in. He's creating his strips and he's planting his cover crop and he's putting on P and K at the same time, all in one pass. This machine is a combination of 3 other machines that he worked with the companies to build. It cost about $300,000 just for the machine that he put together. This is his second or third iteration that he's worked with on that. He is knifing in anhydrous ammonia at this point. My concern with anhydrous, for those of you that aren't familiar, it has thin knives that go and cut through the soil. They put it down about 6 inches deep. The knives are going into the cover crop passes. So they're going into the old roots of the cover crop. And I was concerned that it would be ripping up roots and maybe digging up soil. Just the opposite. It was sliding right through. Looked really good. So this field, that image there, I bent down, took a picture of the corn. So it's out there. You just hard to see at this moment. And then that's them going by. You can see the tram lines here from the passes. Over the tram lines, they do not run the injector knives. They do not want to disrupt those tram lines. And so instead, they've got tanks on the side of the tractor that have 28% nitrogen in them. And so in the tram line, they put in 28% nitrogen. So my picture turned out terrible. I wish it didn't. They got 2 monitors in the tractor, one controlling the variable rate anhydrous, one controlling the 28% nitrogen going on and telling you what the outputs of each are. That's just a picture of the tram line. So, all right, let's get past that. That day, this corn's further along, only about a 2-degree difference. Not a lot of separation there at that point in time. So those temperature differences are going to be year dependent and probably to some extent field dependent as well. But I think there are some interesting things coming out of it. And so again, the day of application and about 3 weeks later, corn's coming along really good and highly evident. The third farm in the area worked with another company to develop this strip till system here. It's basically a combination of a rotary hoe and some no-till coulters that would be on the front of a no-till planter. Doing the same type of technique, the same goal. So they're all putting money into it, trying to invest and figure this out. I would guess, I'm gonna call his name out. I guess Micah is probably because he switched his equipment over to the tram lines, trying to make that work. I would say he's easily spent about $2 million on equipment, getting it switched over and such. Now, some of that grant he's cycling through anyhow, right? Because he's going to trade equipment at least every 5 years, if not sooner. But over that point in time, but he's done all of that with the long-term bet that 10, 15 years from now, those soils are better than they are today. Does that make sense to everybody? All right. So, some of the questions that are on my mind, some areas for us to study, I think, the erosion question is a big one. There are other strip till fields in that area by other farmers that are not this successful. There are some failures out there. Do we really get a better corn establishment, soybean establishment? Can we monitor that? Can we document yield from that? Nutrient placement. They've got a lot of questions. Since he's putting that corn every other year, the corn is going in the exact same spot. He's also doing wheat and beans in this field. He's got questions about where does he place his nutrients? Doesn't matter in there. And then of course, the controlled traffic, soil compaction, those type of questions that we've always dealt with before. Okay, a couple other things that some of these farmers deal with, and these will be quick. So Micah on his phone through John Deere, he's got a John Deere program, and he can track every piece of equipment all the time in his operation. And again, these have come out really pixelated. I apologize. I swear these were higher resolution on the screen. So here's a semi truck. It's traveling. You can't read that, but it says 31.4 miles per hour. It's taking grain out of the field, heading back to the farm to drop off at the grain elevator, at the one that they have on farm. Then here's his other tractors and equipment running. He can click on each one. It tells you what their speed is, how many engine hours, the temperature of the engine, all of those things. These are pieces of equipment that he's got currently sitting by his grain bin system. And then this is an overview of his fields. He's got some that are kind of a green tint and some that are a red tint and some that are a blue. I assume that's corn and soybean and maybe some fields have been planted into wheat. I don't know, but that's my assumption. But he's got one combine up here running. He's got a combine here running. There's a tractor over here. My guess is the tractor's either spreading fertilizer or planting a wheat crop. Again, I don't know. He click on each one, he can tell you. At his grain bin, they're putting corn in the grain bin. The corn's coming off moist. They've got to run it through a dryer before they store it. So the outlet's at 17% capacity, the inlet's at 19%, so nothing's being put in the bin at this moment. These are continuous flow dryers. So the corn that's in the cooling bin, so it's already been dried and now it's cooling, is 191 degrees. And then the corn being dried at the max drying temperature is 231. That's all on his phone. He can adjust it from his phone. And sometimes it works and sometimes it doesn't. Sometimes he still has to go do a manual override. And then everything is kept, his backup is all right there. And usually those are all put together by field. So that individual field, the one slide I showed you all the data, that book would have all of that information by field in that book as a backup. So Mike, you ask what happens? Those sit on a shelf. Every so often they get them out and say, oh, what can we learn from this? I mean, they're doing a lot with it, but I think there's a lot more we could all learn from it. I really do. One of the other farmers runs C&H, runs Case IH tractors. And once he heard that the other guy sent me the John Deere software, he had to show me what Case IH does. Same basic thing. This one's on his desktop computer and same deal. You can click on that, click on that. Click on one of these and you see what the next screen shows you, which is a combine cab. So the combine cab, you've got a monitor here that has several things on it. This is showing you machine performance, the threshing performance going on, rotor speed, threshing speed. It'll pick up temperatures. It's giving you a moisture right now estimate. And it's giving you a yield estimate on the spot as it goes through. Over here, this is generating a yield map with the various colors. It's giving you some moisture, some other numbers as well. All of these numbers he can see on his computer back at the office or on his phone. All of these numbers, John Deere or Case IH can see as well. So there's some discussions on data that way. And then finally, a yield map will look something like this. This is a 30-acre field. These are individual yield results off of those combines. You think about a combine harvesting what? 250 bushels every 5 minutes, 250 times 56 is that many pounds going through about a 6-inch auger on a combine into a loading bin, hitting a pressure plate to give you an estimate of yield. And it's giving you these numbers. So I would argue that each individual data point by itself is not safe, but grouped together, you have a pretty good idea about what your yield is in those areas. And you can take a yield map like this and look at something like your soils map, your basic soils map. Red spot here, different soil type here. Those tend to kind of match up. Slightly different area here than here. And so this is what I mean by adjusted soils map. So farmers are using 4 or 5 years of soils map of yield data to look at their soils map and make slight adjustments in their soils map and say, well, there's actually a little more clay in this area than what the map says. We're gonna treat that differently in there. Okay. Have I put you all to sleep yet? Everybody with me? Okay, this might be the last. So irrigation, a lot of work in irrigation, and Ola just stepped out. This is meant for him. This is looking at your irrigation curve over time. This is showing you the water depth in the root zone. They've got sensors that go down 3 meters, sending this information back to the cell phone. They can look at this, they can have it automated, or they can, with their cell phone, turn on and turn off their irrigation systems based off of what these numbers show them there. And so there's lots of questions we can ask in that realm as well, like how many sensors do you need? Where do they need to be placed? What's the right irrigation rate? How are we timing this? I think Ola's work where he's at, I think it's ready to be tried out in this area here with these growers. All right, I'll leave it at that. You all held in, thank you.
Question. Chad, where you showed the
Sure.
wheat, barley, and rye yield, did you have root yield as well?
No, good question. We don't have root yields yet. We're waiting on some of those to get washed.
Okay,
So,
but you'll have those.
I'm working on it.
But for the most part, we've just done above ground. We've just tried to look at above ground biomass and get a sense of where that's at. So, and my guess is if we're gonna terminate early, probably about 2,000 pounds is probably our max biomass, and then we terminate almost regardless of when we plant the cash crop, or we let it go to the image where you just crimp it over and plant green into it and do it that way. It almost needs to be one or the other. If you're anywhere in the middle, it tends to end up with problems. And that's more from observations on farms than it is from our data, because we haven't tested that many data points. Yeah.
Chad, related to that, I'm guessing maybe Dan did this, the seed-end ratio difference between early and late. I mean, it's like rye or
Yeah.
Barley, it's usually 80-1 or something like that, but if you go earlier, it's 40-1, so.
Right.
It's obviously gonna affect your nitrogen rate.
It can. We do have it all. I didn't show it. And I don't remember what the numbers are, but all of them are that 40-1 or above. And looking at Hannah real quick because she's on the committee too. Does that sound right, Hannah?
Yeah, I remember the highest being the one.
Yeah.
Study, I think.
Okay.
Oh, the straw one, the barley
Yeah.
straw is
Yeah.
pretty high, 68, I mean, it can
Yeah.
be pretty high.
Yeah, which is, it's in a realm that you expect it to be competitive
Yeah.
for nitrogen, right? Yeah. So that's, Hannah's stuff, looking at some of the legume mixes and some of her data. I think barley is going to be the option for our route to go. If a farmer's concerned about erosion, and that's the primary issue, then barley is probably a good option, I think. We'll see if Rob's data actually supports that. And maybe a legume to help change that ratio a little bit, not so much to donate nitrogen to the regular crop. Because you're like that image I showed you. Now they're letting the satellite imagery. I mean, they're letting it get up to here, right? They're trying to maximize that biomass. They knew they're going to be planting late, but they were trying to test that system and see what it would do.
How much cost sharing does a farmer receive in one of these cover crop schemes that you're talking about?
That's a great question. The numbers I pulled off for this year is close to $40 an acre if it's a multi-species scheme. If the farmer's a veteran or fits a couple of other parameters, then it's a little bit more than that for them. But any one farmer will top out at $40,000 in a program. That's the
What
most.
are other conservation stability practices beyond cover crop that are cost sharing?
At times they'll do some for like no-till, even crop rotation, like early on. They won't do it long-term from my understanding. But if a farmer's getting into it, they'll do some of those, and all of those are a lot smaller values
Administered by
So-
ACP,
by NRCS through their
what's that stand for?
Natural Resource Conservation Service, the old Soil Conservation Service.
Okay.
That's now NRCS. Yeah. Yeah. So probably goes back to the same outfit that you're asking about. Yeah.
So Chad, you started out your presentation here talking about regenerative agriculture and
Yeah.
sustainability and so forth. I just happened to come across an article this morning in Farm Journal, which is a popular news source to farmers.
Mm-hmm.
And they had an article on now's the time to transition to vertical farming systems. Now, what caught my attention on that was the fact that just earlier in the week, I drove by a farm in which an individual was headed across the field in his vertical tillage system with a plume of soil, at least 30 to 50 foot tall behind the equipment, even blowing across the road onto an adjacent area,
Yeah.
which in my herbicide world we call off-target movement. So what's the thoughts and then this kind of increase used even here in Kentucky of these vertical tillage equipment systems relative to trying to move forward in being however you want to define sustainability or regenerative
You bet.
agriculture?
I'm gonna answer that question two ways, maybe three. And I'll start with by saying the majority of our farms are either no-till or they fall into the minimum till category. So the majority of our farms are not using a moldboard plow and a disc to go through the field. So that alone is a success story, and that alone would fit into regenerative ag. Now, you and I both would agree running a vertical till system this time of the year in the field is a bad idea and is going to lead to other problems. So while it can fit into the category, it doesn't always mean it's good if it's done at the wrong time. Most of vertical till is taking place in the spring, and it's taking place in the spring because of the slug issue. So case in point, a farmer out in Webster County this year, the last 2 years had to replant crops at least twice because of slugs. 1 year it was 3 times. So this year decided that's it. Did vertical tillage. Actually did some pretty heavy shallow tillage to where there was no residue left. Didn't want any slug issue. Planted corn. Corn came up to about that tall, so it was at VE still, just at the emergent stage. Had 4 inches of rain on it. which washed every bit of those seed furrows out down to where the seed was now exposed again. So a good case in point, a really tough reminder of why no-till works really well in our fields. I'm not going to fault that farmer. 2 years in a row, he'd been fighting slugs in that field. He was trying to get rid of them, trying to fix that issue. The other thing that could be happening though, JD, what I've seen happen and it's successful is folks are using the vertical till equipment with a box on it that they're broadcasting wheat or sometimes a cover crop behind that. Now, if they're doing that and establishing a fall crop, I can see that I've seen that be successful in some cases. But you and I are on the same page that a lot of the vertical till stuff is not helpful. At least it's not a plow, but it's still not helpful.
What exactly is vertical till?
Yeah, well, that's a great question. That's got as many different definitions as regenerative ag has. What the original intent of vertical till was is you took no-till coulters like you would have on a planter, you'd have them swivel, and you just run those through the field. And all they were doing was going maybe an inch or two deep, and you're just chopping up residue to try to help it decompose faster, maybe make it a little bit easier to plant. Some planters aren't as equipped as others as well to handle residue. So it was a way to just kind of handle the trash. That system is, there's some merit to that system. I can see where that works. Most of the new pieces of equipment that call themselves vertical till look and act a lot like a disc. And so when you get into those, now you're getting into some of the bad things that a disc does in the field. Vertical till does the same. They're just doing it at 2 inches instead of 4. Yeah, and so it depends on which one of those implements. And based on JD's description, that farmer was running the disc. It's got a vertical till
With the basket on the
title.
back.
Yeah,
To
yeah.
smooth it down.
yeah.
And in this particular case, this is at least the second, if not probably the third trip across this field since corn harvest.
Tobacco farmer?
No.
Okay. Sorry, where's Bob? Okay,
No, we're talking about a pretty good sizable grain operation.
okay. That's problematic.
What's the additional labor needed for these systems?
For the cover crop systems,
Yeah, or I'm thinking like strip till, you've got burn down, you've got cover crop
Mhm.
planting, you've got to strip till it.
Yeah.
So there's gotta be more labor demand.
so the labor comes here in the strip till and the planting of the cover crop, right? So for the most part with the cover crop, if you think about the spring, we're going to do a burn down anyhow. So you're not, unless you're crimping, unless you're letting it get big and crimping, then there's labor that way. And in the case of Rob's study, if you have to replant, well, that's extra labor for that. So there is some more labor. There is more labor. These farmers would say they've got year-round labor anyhow. They've already got people on the payroll, so it doesn't, they probably wouldn't factor it the way you and I would factor it, trying to figure it out on a per acre basis. It's a good question. Where it really hits them though is if they get a sizable yield loss. It's the other thing we talked about at lunch. While they're willing to do these things, these are all of these cover crops that everybody's doing that I just showed you pictures of. These are all betting 10 years from now, 15 years from now, those soils are much better than they are today. All of that. I think it's a pretty noble bet. But in every scenario, they've got to be able to pay the bills every year in order to keep that rolling. They've got to stay